Are you a nerd looking to find a new trick to impress your numerous friends at your next math club barbecue? Are you waiting for those hot dogs to thaw? Well, instead of standing around looking at this empty grill, why don't you grab those frozen hot dogs and listen up? Some fancy French dude with too much time on his hands named Buffon was fooling around with needles in the 18th century. He wanted to know if he threw them at some lines he drew on the ground, what the probability would be that they landed on one of those lines. He succeeded, and today we're going to tarnish his name by repeating that same exact experiment with frozen hot dogs. So buckle up, kids, because I'm going to teach you how to calculate pi using frozen hot dogs.
Now let's get started. For this experiment, you will need tape. We prefer electrical tape, but any tape will do. A pen, some scissors, a piece of paper, a calculator, and finally, a pack of hot dogs.
First, we're going to set up our basic way of recording crosses and tosses. Take your paper and draw a line down the middle. Write crosses at the top on one side and write tosses at the top on the other side. But I don't think you know what we're doing yet. So here's just a general outline. We're going to tape down lines, we're going to throw hot dogs at the lines, we're going to count the hot dogs that cross the lines, and then we're going to record the crosses and the tosses, and then finally we're going to calculate pi using those values. Take your tape and cut it into strips about 3 feet long. Next, tape a straight line on the floor using those strips. Then place your hot dog next to it so that the tip of it touches the tape strip, and the hot dog is roughly perpendicular to it. Place your next tape strip so that it is at the other end of the hot dog, parallel to the first. Now you're going to keep laying these bad boys down until you fill your throwing area. We chose to make 6 strips, so we were able to land our hot dogs on at least one of those lines. Now the fun begins. Take a few steps back and start throwing those hot dogs at the tape lines.
Overall, you're going to want to throw about 100 hot dogs to get an accurate estimation of pi. Any hot dog that doesn't land outside your lines, like this one, counts as a toss. If a hot dog crosses the line, it counts as a cross. If it is between 2 lines, it is not a cross. Now let's get on to the math. First, multiply your total number of tosses by 2, and then divide that by your total number of crosses. Now, this might be a little bit of hard math for some of you, so enter it into your calculator, and that will give you your estimation of pi. So tell me, how close did you get?
Now that you nerds are done with the experiment, we're going to explain some of the boring math behind it.
We're going to go over all the math for this hot dog experiment. We're going to go from the probability equation to the famous Buffon needle experiment equation to the simple algebra that you will be doing for your experiment at home. There is a lot of calculus in this, and there's a bit of trigonometry, so try to follow along as best you can. I'll try to explain it as I go. It shouldn't be too much of an issue. The probability equation is just stating what is the average of the function over a period of the function. So the function we're going to use, that Buffon led to, is the length of the hot dog divided by the distance between the lines of the grid that we set up earlier when we set up the experiment, times the absolute value of cosine theta. Why the absolute value of cosine theta? If we throw the hot dog can land anywhere in a circle. So we need to take account all the degrees of the circle that it can land in. And that graph comes out to a cosine graph here. We also want all the values to be positive, so we're going to take the absolute value of this graph and all the values will become positive. If we plug in all of those factors into the probability equation, we'll have the Buffon needle experiment equation. We're going to try to simplify this now. So L is equal to D because we made the distance between the lines using the hot dogs. So if L is divided by D, we're going to get 1. So those can cancel out of our experiment. The absolute value of cosine theta, I'm going to take the absolute value of cosine theta from 0 to 2 pi and realize it's 4 equal sections of the first quarter of the graph. So instead of taking the absolute value of cosine from 0 to 2 pi, we're going to take 4 separate integrals of cosine theta for 0 to pi over 2, the first quarter of the graph. When we plug those instead of the original equation, we'll have 4 over 2 pi of the integral of cosine theta from 0 to pi over 2. This here comes out to 1, leaving us with just 4 over 2 pi, which comes out to 2 over pi. So probability is equal to 2 over pi. Probability is also equal to the crosses over the total number of tosses, because that's what we were trying to solve for originally. So we could say crosses over tosses is equal to 2 over pi. One last math maneuver, we can say pi is equal to 2 times the tosses over the crosses.
Maybe that math wasn't as boring as I thought. Now you can bring pi to any barbecue you go to, as long as they have frozen hot dogs. See you later, nerds.